All right. Good morning and good afternoon, everyone out there in solar land. Welcome to our webinar entitled Microinverter Tax. Not all DC to AC ratios are created equal. Thank you for joining us today here on this beautiful tax day, April 15th, 2025. We promise we won't take up all of your time today. You still got a chance to run out there and finish your filings or hopefully maybe do an extension if you need to do that. But we're joined here with Joel from Energy Sage. We'll get to our intros here in just a second, but let's just hop right into it. We got a lot of action-packed trends and data to present to everyone today. So here's the agenda, and we're going to go over just a quick brief at the very beginning about who Tigo is and who Energy Sage is, and then we're going to jump right into it. The trend lines, what we're seeing out there in the industry, as far as where modules are going, where batteries are, of course, more and more are getting quoted and attached, as well as the ever-rising utility rates out there. And then, I mean, the core of what the day is today, we'll get into our true taxes of the systems that are going on out there. We'll present to you the Tigo solution of DC coupled system. And for those folks out there who aren't already on the Energy Sage platform, then we've got a special offer to you there. Joel will get to that at the very end. Before we jump right into it too, I want to make sure there's a question box there on your screen. Please feel free, ask us some questions. We'll try to get to them live, but we also have some time allotted at the very end for some question and answers. And then we also have a tab on there for resources that we'll be referring to throughout the webinar. So quick, accessible links there to access everything. All right, with that, it's our pleasure to have Joel Su, the Senior Strategy and Operations Manager from Energy Sage, join us today. He's got been with Energy Sage for over 2.5 years, extensive work throughout with the Energy Sage installer network. But now he's manufacturing both manufacturer and channel partnerships. We've got John Lurch, Global Marketing Senior Director here at Tigo, who's coming in with over 18 years of experience in the energy sector. And myself, Mike Gazzano, I'm the North America Marketing Manager, and I have over 15 years involvement in the renewable energy space. So it's a pleasure to have everyone here on the panel here with us today, as well as our audience out there in the solar world. So here's just a brief couple bullets here for Tigo. We were founded in 2007 in Silicon Valley here, beautiful Bay Area in California. And we're a leader in MLPE, or module level power electronics. But we're also a full energy storage solution provider. We have tens of millions of units deployed across all 7 continents, and that's what these green leaves here represent. So everything down to Antarctica, out to the Australian outback, to here in the US, Europe, Africa, you name it. We're monitoring over 1.5 gigawatt hours of daily production at the module level. So not system, but all the way down to the individual modules. We're involved in pretty much the full gamut of solar production there in the residential, commercial, and utility spaces. And we're also publicly traded out on the NASDAQ market. So here's just a brief, again, kind of our Tigo mission is to deliver smart hardware and software solutions that enhance safety and increase energy yield at the same time while lowering your operating costs throughout the residential, commercial, and utility scale of the solar solutions. And in that middle chunk, we really say that Tigo offers a true kind of one-stop shopping solution there with our MLPEs, including our optimizers, our Go ESS and EI residential home systems. And then what really brings it all together is our energy intelligence platform that handles on both the monitoring side, but as well as then with the installation of the EI residential, it's your commissioning software. So really kind of one area, one hierarchy there of Tigo that can help you throughout your solar journey. With that, I want to pass the microphone over to Joel for a quick Energy Sage intro. Joel?
Thanks, Mike. Hello, everyone. Looking forward to this conversation. Before we dive into this, wanted to give you all a brief intro on what we do here at Energy Sage. If you're in the residential solar space, you might be familiar with it. But anyways, just a high-level intro. Energy Sage, we're the #1 trusted site for homeowners to get educated on whole home electrification. Over a decade ago, we got our start in residential solar with the Department of Energy's Sunshot Award to build the first ever residential solar marketplace. Today, our consumer-first approach to solar attracts approximately 8 million visitors in web traffic annually, and our solar marketplace has supported over 1 million shoppers. Next. A little bit more on how we do things here on the Energy Sage, the solar marketplace. We like to call ourselves the Expedia of solar, where homeowners can sign up, receive quotes from our installer network. More relevant for you all on the installer side, installers can get access to highly qualified opportunities to help homeowners go solar. For every homeowner that signs up on Energy Sage, we make sure to vet the quality of the property so our installer network doesn't have to. As about summer of last year, we've been open in 50 states and DC. So that's a little bit more on what we do here at Energy Sage. We've expanded into other verticals as well. Again, beyond solar, into heat pumps, EV charging, storage, rooftop solar. So those are the areas we're in now. All right, that's it. Mike, John.
All right, thanks guys. So you got the brief overview of who we are, what we do. Now we're going to jump into really the core content of this, which is around the microinverter tax. As a reminder, as Mike said, you got a panel on the right side with some resources. We're going to be touching on those, including a 7-part series that's all written out on the microinverter tax for anyone that wants to dig in and use some of the sources that we're going to mention in here. And we are doing this live, so we'd love to see questions start to come in. We're going to address however many we can get to, real time, and we're going to save some Q&A for the very end. So hopefully we have some questions from the audience. It'll help enrich our dialogue here. And one thing I want to come out kind of right out of the gates and say is a lot of this is going to be focused on microinverters and AC coupled systems versus DC coupled systems, so like hybrid string inverters. I don't want to take anything away from the success that microinverters have. They've been instrumental in getting us to where we are on residential solar installations. But what I am going to show here, starting with these trends, is to start to talk about things that are different and becoming more different now that might expose some deficiencies in some of that AC coupled technology. Okay, so again, nothing to take away from them, but let's take a look at what these trends are, and then we're going to quantify some of the effects on microinverter and AC coupled systems compared to DC coupled systems. So the first trend is increasing module wattage. I think it's no secret, everyone's seen this in the industry. If you've walked around a trade show, you see these massive modules now, 700 watts plus in many cases, bifacial. Well, the module wattage increases aren't just on those large commercial and utility sites. Here I've charted the average installed residential solar module wattage, and you can see that it's crept up steadily, hitting 400 watts in 2024. And I'm going to quote directly from Energy Sage's first half of 2024 report, saying 97% of all quotes that they saw in the first half of 2024, so not even the second half, were over 400 watts. And we got a link to that report. It's an excellent read on the right side. And the big takeaway here I have is these higher wattages are becoming the norm, driven by lowering, LCOE for customers.
John, if you don't mind me jumping in a little bit more on just the recent numbers I've looked at. This is not necessarily released yet, but looking at the past 90 days, approximately, I think the top 20 most quoted modules on the Energy Sage site, they're all over 400 watts. So and that represents something like 85% of all quotes. And so it's still around that trend line, and it's we'll release the data once it's all done and published, but it tends to be trending upwards naturally.
Yep. Yeah, very cool. It's cool you get such good granular visibility to what's going on there too.
Yeah.
Okay, so module wattage is trend number one. Trend number two, battery adoption. Yet I'm going back to that same Energy Sage report that's showing an increase from the first half in 2023 from about a 10% storage attach rates on the quotes, jumping up all the way to 40% just 1 year later. And what we're seeing is solar and storage used to be the solar industry. Maybe there was a battery industry. Everything is combined. Solar plus storage is now becoming the norm on residential systems.
If I could voice over that part too, just looking at the same past 90 days, this has to do with quotes. The number what I've looked at recently is past 90 days. This number is, instead of 40%, it's now in the territory where it's the majority. And these are not just quoted; these are actual attached closed deals as well. So again, trending upwards there.
Yeah. So that that green line that's going up and to the right seems to continue going up and to the right. And I think, obviously California is going to be a mix in there, but I think we're also seeing other states like Illinois. I think I've seen Florida jumping up in some other data where it seems like a lot of policy decisions are starting to augment and accelerate this adoption rate. It's not purely just for backup power. You guys seeing that too?
Yeah, I mean, there's the policy part. Naturally, also you're seeing this grow on the homeowner demand side. They're getting more and more educated on batteries, the equipment itself. So this is driven on the sort of supply side, but on the demand side, customers are asking for it too.
You got to think, Joel, is it something there too? You guys have expanded the electrification of the home, right? We're talking, of course, EV chargers out there, the heat pumps, induction stoves, everything else. Like you said, it's the demand, right?
Mm-hmm. Yeah. Naturally, all of these homes, they're just trying to accommodate for larger consumption of energy because of this trend towards whole home electrification, right? Everything is just, especially the heating and cooling side. It's just more and more consumption, and they're trying to accommodate for that.
Yeah, very cool. And it's all linked because the rate plans are incentivizing the appropriate usage or lack thereof. Yeah. Okay, so trend two, battery adoption. Let's keep it moving. We have a lot of content in here that we're going to be covering. Rising utility rates. This one's also no secret to folks that are used to paying their electric bills. So for the last 4 years, the average increase has been 5% per year. Things really started to ratchet up around 2021. This is U.S. residential electricity rates. So pulled from the EIA, you can go ahead and check it out and dive in there. There's different states that have different factors. But the onward march up and to the right continues. And what this means is that every kilowatt hour that can be produced or saved is becoming more and more valuable. So it's going to be more and more accretive to your unit model economics for solar. Okay. So that's kind of an underlying piece in all this. And when you'll see I do some savings calculators. They're factoring in utility rate escalations and relatively high, dollars per kilowatt hour. Okay. So 3 trends. Now we're going to have a little fun playing with some AI generated image. Some patriots that were unhappy with taxes being placed on them back in the day. So we're looking at the Boston Tea Party. And so
love the Boston reference.
Yeah. So, I view, and we're going to extrapolate on every single one of these, but these trends are not just really creating, but maybe growing a microinverter tax. And I want to be really clear, especially with all the stuff going on in the world. This is not a literal tax or tariff or anything of that nature. I'm using it as an analogy for additional price paid or feed based on the technology stack compared to a different technology stack. So in the old world, microinverters are fantastic, on either smaller sites, simpler installs, non-battery systems. They've been, awesome in getting us to where we are today. But in the new world, with those trends that I just described, the increasing module wattage can lead to clipping with microinverters. And we'll touch on that. Growing battery adoption, well, now there's conversion losses with AC coupled batteries. And then rising utility rates, already touched on this, amplifies the cost of every lost kilowatt hour of energy. So those are going to be kind of the 3 focuses for our next section. All right, so let's dive into these taxes. And again, not real taxes, it's a metaphor. I don't want to get into trouble in here. So the clipping tax, what is clipping? Hopefully everyone, I would imagine, has heard this. You've certainly seen it if you've been around some of the Reddit R solar message boards. But basically it occurs when the power from the solar module that it wants to generate is greater than the max capacity of the inverter. So in this case, we have a 425 watt rated module at STC and a 325 watt microinverter. If that module is trying to generate 425 watts, it will only generate 325 watts. The delta is clipping, 100 watts in this case. Makes sense? And to be clear, I'm using a microinverter in this example. DC or string inverters can clip too, and we will dive deep into that. And people say, how do I know my system is clipping? Well, the telltale sign that you'll see all over is when you have a nice looking production curve that suddenly gets clipped off. Okay, so it's got this flat top, and you can see, a little bit of snarkiness in here in some of the Reddit solar threads. Someone please explain clipping to me. Your inverter hit its max output. That's exactly what's happening. I encourage folks to go search clipping in there and threads. Okay, and there is also a lot of context in those threads. It's really fascinating to read. We're obviously coming about it from one side, but go ahead and check it out. Do it for yourself. And people tend to not like the shape of those curves. And in some cases, it might not be that big of a deal. In some cases, these numbers can really add up. So if you extrapolate out just 3% average clipping over the lifetime of a project, that can reduce savings by $10,000. Calculate 10,724 on this. I assumed a 15 kilowatt system, 30 cents a kilowatt hour at 19% capacity factor, 5% utility rate escalator. I'll keep coming back to those numbers in a few examples. So when you had, this savings, it's not just clipping your energy, it's clipping your savings, and every kilowatt hour is getting more and more valuable, as we demonstrated earlier, right? So to zoom in on this and what it might look like, so you saw that was a leading microinverters production curve. Here's a production curve on a Tigo system. If you had 300 watt micros on this site that has 32 450 watt modules, and we picked this day, so those 300 watt microinverters would be clipped. Okay, you'd be clipped right there. All of the green above that red line, that energy would not be produced. If you had 360 watt micros, all of the energy above that line would not be produced. Okay, so that's the energy that would be lost. And now everyone wants to know, okay, so how much is my system going to clip? What's the real delta and the DC to AC ratio and everything where it's going to be affected? I'm actually just going to use, this is a study from Enphase, who's the leading microinverter manufacturer. There's really 2 key components that are going to affect clipping. Well, maybe 3. One's going to be the orientation, but this doesn't address that. It assumes similar orientations. So the other is the delta between the module wattage, which we know is increasing, and then the location, which, the proxy for the, quality of the sun or the irradiance levels. So in this example, this assumes a 300 watt microinverter across the board. If you're in Denver, Colorado, 435 watt modules, that's 3.7% clipping on your one. Makes sense. So the higher up you go on the module wattage, if you keep that microinverter fixed, you're going to see more clipping. Obviously, there's options also for microinverters that go higher than that. I don't want to make it seem like it's only a 300 watt option, but those come at different price points and voltage ranges and other things like that. Makes sense. And then the last thing, and I want to circle back to that marketplace report. So Joel already double clicked on this, but I like this quote: the higher wattage solar panels continue to skyrocket in popularity. So this trend is not going away of the higher wattage ones. It'll be interesting to see how some of the microinverter systems kind of keep pace. And I do think I'm going to keep going to the monetary aspect of this. I do think there's an emotional one that you also see in those Reddit threads of customers don't like the idea of having energy clipped off and seeing it in their production curves.
Yeah, it always feels like it's money on the table, right? You already have the equipment there. I would add, and this is purely anecdotal, but it feels like it could drive home a point. In my conversations with module manufacturers, I'm hearing a lot of the lower wattage ones are just straight up being discontinued too. So again, this is more of the demand for higher wattage modules is there, but even on the supply side, those are becoming less and less too.
Yeah.
So, yeah, figured I.
Yeah. It makes sense because if you think of trying to do a site, if you have higher wattage modules, that means you need less modules to achieve the same, rated output, which means you need less either microinverters or MLPE, you need less racking, you need less people to physically move each one. So it helps all of the downstream unit model economics for the project.
Yeah, 100%.
Okay, and now I gotta tease the battery side of this and why batteries can work so well with these solar installations that might be, say, have higher DC to AC ratios. If a hybrid or inverter is used, which allows the battery to be DC coupled. So we're going to dive into this in a future section, but I want to double click on it here because I focused on microinverter clipping. String inverters clip too, but on average, they're going to clip a little bit less. And string inverters have this superpower that if it's coupled with a DC coupled battery, the excess energy production beyond the inverter nameplate can actually go directly to the battery to charge it. So pretty darn cool. Can avoid clipping as long as there's battery capacity to be charged in a system like that. And as we saw, batteries are becoming the norm. So I want to hold on to that, and then I'm going to go into why, even if there's not a battery and you have two systems that both have the same DC to AC ratios, string inverters on average should clip less than microinverters. Okay. So we call this tax 1.5. Micros on average are going to clip more. And this, I felt like in the ebook, which again, accessible on the right, is worth its own whole dedicated section. We call it like a clipping showdown. It's chapter 7. But let's dive into it, and we're going to get into the weeds a little bit. So assume we have a 15 kilowatt site. There's 35 440 watt modules. You have a west array, and you have an east array. And then I map out what those look like and the max production of each. And in this case, we're going to compare an 11.4 kilowatt string inverter versus 11.4 kilowatts worth of 325 watt microinverters. Now, at this moment, the sun is shining on the west array. So it's trying to generate 400 watts on that west array, only 250 watts on the east array. So a total of 11,300 watts or 11.3 kilowatts. That option one I talked about. So say you have optimizers on here, DC optimizers, 11.4 kilowatt inverter. The east array is going to do its thing at the same. The west array is going to hit that 400 watts per module. You end up with 11,300 watts, which is under the 11.4 kilowatts. for the string inverter. So no clipping is occurring. If you look at a microinverter, so the reason why these DC to AC ratios aren't created equal, microinverters clip at the module level. So any individual, either array or module that is exceeding that inverter's capacity is going to be clipped. So the East array, no problem, 250 watts and a 325 watt microinverter is generating the same. But that West array that wants to rev up to 400 watts, well, that's only going to hit 325. And so as a result, when you kind of sum it out, it's hitting 10,025 watts. So that's 13% clipping at this period of time. So a delta of, 1.3 rounding up kilowatts. Yeah. So that gets into some of the specifics. And another way to visualize this, if we look at, say, the performance over the course of a day, with that green line being that same total power output, what's happening in the string inverter site is when that East array is producing a lot, the West array is producing a little bit less, and vice versa, and they tend to balance each other out. So the string inverter with no battery is only going to clip if the global maximum exceeds the inverter capacity, right? What's happening now with the microinverter, that East array wants to rev up, boom, it gets clipped at the 325 watts per module. And so that brings down the total power output. And then again, when the West array wants to rev up, it's getting clipped at that 325 watts. In this case, with the multiple orientations, you might not even see that totally flat curve like I showed before. So it might be more hidden, but clipping could be occurring. So I want to say clipping doesn't only occur when you see it as a flat curve like that. It can be occurring and it can be hidden. I know I just threw a lot of stuff at everyone. This makes sense. Yeah, Mike and Joel, there's a lot of numbers, a lot of charts, a lot of graphs.
It's a great representation, though. Yeah, I like the visual aspect of it.
Okay, cool. And again, if anyone wants to read in on it, I got a link to it on the right. Mike, were you going to say something?
Oh, no, I was just going to say, I think just even around my own neighborhood in the Bay, going out for walks and whatnot and seeing, you can kind of tell those old school residential solar installations that maybe only had one side up there, getting the most sun possible on the south side. And then you come across maybe a newer installation where ultimately practically every square inch seems to be covered up there with modules and truly trying to take advantage throughout the day. But again, if there's these hidden clippings that are happening throughout the day or not taking full advantage of the module's potential output there, I mean, I think again, it's that emotional side. It's a pretty heavy investment for a system up there. You want to try to get the most everything possible out of it.
Yep, totally. And what we're seeing, like you're describing, is homes, especially going forward, to accommodate now for an electric vehicle, for heat pumps, for induction stoves, for, could be even taking advantage of like NEM, where there's more value in the morning and afternoon. They're doing multiple orientations. It has the effects of flattening out that production curve, but it also, sometimes you just need the roof space. You're going to generate more electricity that way. Homes are now starting to ratchet up in the electricity consumption category because of all of those additional electrical technologies I was describing as well. Okay. Oh, and I see we have a question. Thank you for putting that in. It's a long one. So I'm gonna summarize this real quick because I want to let's get some more questions in here. I'm gonna save some for the end, but let me summarize this real quick. So respect and appreciate the perspective, but I'm curious. Mods can produce higher wattage, for example, 425, but it's at STC, standard test conditions. So my understanding is they will not always clip depending on the weather conditions throughout the year. Can you share your opinion on appropriate ratio to minimize clipping when you have a consumer who wants a micro over string for whatever reason? How can you do it ethically but still serve your customers? Okay, that's a really good question and a complicated one. So it is part of the reason why I wanted to show this is based on, the leading microinverter's own study, how they chose to do the study. So clipping is not going to be equal. Even in these regions, different homes are going to have different, levels of clipping. And it is typically not going to be year round, and certainly not every day, because there's going to be different clouds and other things like that. What I can share, though, is it's typically most common on kind of spring days like this and fall days where it's actually a little on the cooler side, but that sun is revving up. And we've seen typically the modules aren't hitting that STC, but I can also show you examples where they've even increased and hit above the STC. So it's hard to give this is the best DC or AC ratio that's going to conquer all. But what I will say is, if you are coupling your system and you go DC optimizers with a hybrid inverter and a battery, even if you have a higher DC to AC ratio, that excess solar production can be used to go charge the battery. That's just not the case with the microinverters. And if you want to minimize clipping, what you got to do with microinverters, you start going up the higher and higher wattage. But there are trade-offs on price and voltage ranges when you do that. I'm not going to speak for what the ideal is for those guys. I think they probably have enough documentation and stuff on that. Okay, great question, though. Love to see it. Keep them coming, guys. So I talked about the battery coupling being a wonderful way to take some of that excess production if the production levels are above and beyond what the inverter nameplate capacity is. So let's get into how those batteries might be used. But first, want to recap the storage trends. So now this is an actual screenshot directly from that Energy Sage report. And I'm bringing in, instead of just the pure numbers, but the quote, over 90% of the installers that they surveyed expected annual battery installations to increase over the next 3 years. And Joel, do you mind commenting a little on how you guys do those surveys? Because I think it's really, you're bringing data, but also kind of some anecdotes and some opinions from the installers in your network as well.
Yeah. I'd say we either run this on a quarterly or half-year basis. We typically, the way we run these is we try to look at what the latest trends are in the solar industry. We try to help the community, folks connected in the Energy Sage network, see around corners by reaching out both to our customers, some customers, and definitely the folks in our installer network, right? And in the case of, late 2023, all of 2024, batteries were really the story when it comes to equipment, the story of solar. So we try to run these with some of our partners who also have installer networks. I believe we did one with PV Mag. We reached out to their installer network as well. And I believe it was another distributor too. So it's how we typically run it. And batteries was one of the bigger questions we had.
The hot topic for sure.
Yeah.
Okay. So we've established batteries kind of really becoming the norm with solar and storage. Most folks expect it to grow even more. So I want to talk about a little on the architecture side of when you couple microinverters with a battery, or we call it an AC coupled system, versus say optimizer, DC optimizers with a hybrid inverter and a battery, which is a DC coupled system. So with a microinverter and battery, you have 3 conversions taking place. Each time a conversion takes place, energy is lost. The physics people will tell me energy can't be lost, but you're losing kilowatt hours for your homeowner at the end of the day. So 3 conversions: module to the microinverter. So that's number 1. That's turning it from DC to AC. Then you have the inverter to the battery. So that's another AC to DC, then battery back to the home. Each conversion, again, you're going to lose some. Now, in a DC coupled systems, we have DC optimizers with that hybrid inverter. So solar is being produced in DC. It remains in DC all through the inverter and can be used to go charge the battery. It's a very efficient way to charge the battery. And then the conversion takes place when you want to use the energy from that battery or any of your solar too. So there's one conversion taking place to go to the home. Okay. And a very timely, good question here. Oh, save for the end. Where do rapid shutdown devices fit in? So we'll double click on that. But these, when I'm using the term optimizer, it's doing not just optimization to minimize impact and shade, but it is also doing module level monitoring, and it's performing the rapid shutdown requirement that's part of NEC safety codes throughout the United States and now more and more of the world. Okay. So those are the three conversions that are taking place. Like everything we're doing in here, we're going to quantify it. So when you map those different conversions out, the DC side that I showed still has losses. There's losses in the battery. There's some inefficiencies, other things like that. Those come out to 8.2%. And granted, some of these are going to be a slightly different depending on whose technology you're using, but these are rough averages. On the AC coupled side, the total losses are 13.3%. That's a delta, that's 62% more losses, or nominally 5.1% of all the energy coming in and out of those batteries is not going to benefit from the homeowner. Okay. So again, this is the difference between one conversion and three conversions. So, and I see a question about how much energy is lost from the panel to the Tigo optimizer. This isn't a conversion, but a running cost. So you can actually see I have PV to MLPE. Great question. PV to MLPE, and that MLPE, module level power electronics, could be a microinverter, could be an optimizer. But there is a little bit of a dark bar there, and that is, I believe it's about 0.3% that because the optimizers were running, I got to double check that, but optimizers are running high 99 point something high percent efficiency. So there is a little bit of a loss there. Again, with optimizers though, all of that is completely, overtaken by the benefit they provide by minimizing shade. But wanted to be fully clear, there is a little bit of loss there. The microinverter loss is in the neighborhood of about 3% because that's 97% is roughly an inverter efficiency. So hopefully that answered your question. Trying to be, as upfront and fair on both of those as possible. The reason that those efficiency numbers matter more now than ever is because rate plans are incentivizing almost daily use of these batteries. So the efficiency wouldn't be that big of a deal if it was just for some home backup. I mean, you would lose 5% of the energy you were hoping to use if you're relying on the grid outage, which is a bummer. But now that is, it's even more exacerbated when there's schemes like NEM 3 in California, where they are incentivizing or almost requiring for unit model economics folks to charge their battery and then discharge it every single day. So what I've shown here is a typical day, and what you're seeing at home energy consumption in the gray, that solar energy production typically ramps up above home energy consumption in the middle of the day. And it used to be you could send that to the grid for like 30 some odd cents a kilowatt hour. Well, California capped that or reduced it by like 90%. And so you get almost no value for sending that energy back to the grid. Instead, the optimal thing to do is to charge a battery, and then you can, so it's using excess solar production, and then you discharge that battery in the afternoon as your solar comes down, your production comes down, and those on-peak rates that in California are like north of 50 cents a kilowatt hour, okay? When that's happening every single day, you can burn through a lot of energy.
John, I would say California and the utilities reducing is saying that politely. I think they royally chopped those rates. you've done a nice job with the charts here. I'd say to any folks out there too, Kelsa does a phenomenal job getting into the true nitty gritty of the full mapping here of the off peak and on peak charges. But yeah, I mean it got to the point that yeah, it's no longer just a backup. It's a daily way of life essentially for the batteries now.
Yep. In this, there's been a kind of common refrain in the solar industry of so goes California, goes the rest of the states from a policy perspective. This is where we're seeing them creep up in other parts. And we could do a whole separate webinar on duck curves and what's really driving that. But regardless, this is what it is. And it's incentivizing people to do the batteries, increasing the attachments rates. And then it's incentivizing people to use those batteries regularly. When you use them regularly, you pay a price for conversion losses. So if we tally up 10 kilowatt hours of daily battery discharge at that same 30 cents a kilowatt hour, 5% escalator over 25 years, it's $2,654 from that 5.1% additional loss on an AC coupled system. And again, this isn't just microinverters. They happen to be AC coupled. This would be for really any AC coupled system. Okay. So it's taking your savings that might have been clipped off the modules and now it's dipping it down. Our stack of cash is getting lower. All right, let's keep going. I want to make sure we have time for even some more questions. The last one, this isn't going to be a performance tax. This is more on the equipment side. So I want to bring back the same, simple energy flow diagram I had earlier showing DC to AC and those 3 conversions. Well, what comes with those conversions is additional inverter capacity as well. You now need, with a battery, again, you need inverter capacity on the modules, right? That's going DC to AC. You need a separate inverter capacity for the battery. So total for this site is 21.4 kilowatts of inverter capacity. And if you compare that to a DC optimized system that's got a hybrid string inverter, that string inverter can handle both the solar conversion process as well as the battery conversion process. So one piece of equipment does both. It's only 11.4 kilowatts, and that will handle everything you need on the module side and on the battery side. So it's just physically less equipment. It's doing less, work throughout the day. And I got to give a shout out to our friend over at Solar Time, who I also want to be clear, check out this video. She does a fantastic job reviewing different technologies. She uses microinverters, so I don't want to paint a picture that it's all negative. She uses microinverters. She also uses string inverters. But I do want to call out one of the elements of this is now we have inverter capacity with the battery. We have inverter capacity operating up on the roof. That's more components up there under the heat that are doing a lot of work, and those can be harder to either replace or maintain if that leads to a higher labor cost, as Martina's saying here, if you do have to do anything to them. So another component of that, whereas a string inverter system, all the inverter, which is really doing a lot of the work of the system, that's all, in the garage or on the ground level on the side of the house. Okay, that is the equipment tax. And then really to kind of summarize how these issues can add up, giving another shout out to our friends in Boston. We continue to use that 15 kilowatt solar plus storage site. Clipping taxes, we calculated up to 10,000, assuming that 3% average annual clipping. Conversion tax was 2,600. That's from the battery, that triple conversion. And then the equipment tax, 88% more inverter capacity that you're paying for. So you're paying for more equipment that's causing also this worse performance potentially. So the total here is 13,378 with more inverter capacity. And now we've already alluded to this, but there's a better way. We've been talking about these DC coupled systems. So I don't want to get too much into the Tigo system because that's obviously one of the things we do, but I am going to shed a little bit of light on it. And I hope folks, keep keep thinking of questions. I've been covering a ton of material. Maybe you're clicking on some of the stuff on the right and even want to ask questions about that Energy Sage report or something we put in the whole ebook. But we like to say declare solar freedom. So another, famous historical figure that AI did a remarkable job generating, holding a solar panel. And, famously, they were trying to get out from under the British rule. In this case, it's solar freedom to get out from, these potential taxes or negative performance impacts. And really that's through optimizers with string inverters. So with Tigo optimizer, there's no real module restrictions, or I haven't seen hardly any. We go up now to 800 watts on the module, and you can use the same MLPE for residential and commercial. You get fewer conversion losses with a DC coupled battery, and then that same inverter can be used for both solar and batteries. I really view this as an efficient and preferred tech stack for, where all these trend lines are headed. So that was the, kind of the high level. And then here it is, and where you can see each component on the roof. And this is where I want to double click on that question about rapid shutdown devices fitting in. All of are that Tigo TS4, and that's been our bread and butter since we were founded back in 2007. That's doing DC to DC, either optimization with module level monitoring and rapid shutdown, or there's also options for just rapid shutdown or rapid shutdown with monitoring. So super efficient. Because it's doing DC to DC, that is not going to be clipping any of your production. And then you do have a transfer switch to assist with backup. And then we have our inverter options, all of which are energy storage ready or hybrid inverters. So we have 3 different sizes, and then our batteries work seamlessly with the inverters. So this is a super efficient way to go when you're looking at working with the higher wattage modules, when you're looking at doing energy storage with your system. And those TS4s that I mentioned earlier, I'm going to skip ahead, that work for virtually any module. A lot of reason why folks like microinverters is they want to be able to minimize the impacts of shade, which this does. It has a similar optimization feature. And they like that visibility, and their homeowners like the visibility to what's going on at the individual module level. So over here, you can see the overlay taken from our monitoring portal. That's Energy Intelligence. That's the wrapper that does not just kind of the hardware functions that everything needs to do, but also the monitoring side. It basically makes a digital twin of every single module, and you can see what's going on today. You can go back in history. You can chart them over time. We have a cool case study that shows what happens at a Harley-Davidson dealer during the solar eclipse in upstate New York, with all of them coming down and then ramping back up. So amazing visibility that not just homeowners like, but installers, as you do 10 sites or 100, but 500, 1,000 or more sites, it lets you dial in and see what's going on. If you get a homeowner call and say, hey, I think I have an issue here. Well, you can go dial in remotely instead of having to roll a truck over to that site. So a huge potential O&M savings for folks, because these are, we've been projecting 25-year project costs. These are 25-year assets sitting up on the roof. I feel strongly it's worth knowing what's going on with each one instead of just string level data.
Hey, John, I wanted to peg on that too, that I think we even go back, and Joel mentioned earlier, it's an emotional side. So now here's a visual reference point that the homeowners can take a look at that pretty substantial investment that they've done to a home system there, and able to see module by module what their system is doing. And then also to come back on the remote monitoring, I've heard from several installers too that maybe there is something that the homeowner experiences and contacts their installer. Well, they're going out and making a call, mainly seeing it from the office first. But as they're getting the truck ready to roll out there, they're also taking a look and seeing how their other nearby systems are functioning. And they're able to give a little bit extra nudge on the customer service side that a couple blocks away, they just say, hey, we noticed something, let's pop by your house and check it out. It's amazing what data can come out of our EI platform. Truly amazing.
100%. I would say back on the consumer experience part of this for those who are on the installer side. Getting ahead of it with customers, being able to just give them a heads up, letting them know about these things. It just really builds your own reputation within the community and for the customers themselves too. So, you know, everyone's trying to build their business by word of mouth. This is a really good way to do that.
Yeah, awesome. I'm glad you brought that up because so much of the time we focus on the installer side and O&M reduction, but it can really be an amazing sales tool or sales enablement tool with homeowners being like, hey, check it out. You know, look what I can see on mine. They tell their neighbors or friends, and suddenly other folks want a similar system. And in many cases, it's the most visible aspect of the array. Yeah, you might see it on the roof, but people often interface the most with it through what's going on in the app.
Yeah.
Okay, I want to make sure we have time for some Q&A. So I want to wrap it up. Last little bit of artificial intelligence generated fun. Don't let microinverters clip your wings. We're having some fun with this on the production curve side of things. So stick to the DC optimizers and hybrid side, and you won't get clipped like this poor peacock here. So be thinking of questions or put them into the chat. And I also want to note that every webinar that we do is hosted on demand after it's live. So after this, you'll get a link to it, and you can check out a whole list of stuff that we've done previously as well. So make sure to check that out. And I want to turn it over to Joel a little bit for a special Energy Sage offer. Yeah,
sure thing. Thank you, John. Just for folks in this webinar, and you know, for the folks that will be seeing this offline, the recorded version of this, we have a special offer for all Tigo customers, Tigo installers. If you are an installer and you want to grow your business on Energy Sage, reach out to me. Let me know. We have waived onboarding fees for anyone that reaches out, just for folks within the Tigo network. You have my contact details down there. And I believe we will send you our contact details and all the relevant links after the webinar too. Awesome. Thank you. Yep, we got that linked on the right, or shoot Joel an email. Our emails are even linked here. I see questions about some inverter compatibility, and I'm so glad I got this. So I want to scoot back here. We focused on the Tigo system that includes the inverters and batteries and transfer switch. So one-stop shop for a home residential solar setup. But from the very get-go, we are an open ecosystem with our TS4s. So actually these TS4, this is a TS4 XO, but our TS4s and our optimizers actually end up on more third-party inverters than our own inverters, and that's across residential and commercial sites all over. So we pride ourselves on being an open ecosystem. We do get a lot of inverter compatibility questions, so we've built an entire database that's accessible on our website. So if you go in under resources, you can look at our inverter compatibility lists right there and see who's on the compatibility list. And also if you need PV rapid shutdown, who is on that list as well. And then lastly, there's a form on both of those pages where if you don't see an inverter listed, send us a note and someone will follow up with you saying we are adding this to the queue, or maybe there's enough that we can see from the sites that are already operating where we can say, yep, those should be good to go. So that being said, for the vast majority of inverters, we do work with. It's just a matter of typically doing the testing, and then we get a letter with the inverter company and put it out there on the website. Okay, so great question. Go check it out. Are there any other questions? We've had some really good ones today. And this is probably the right closing slide because we touched on that marketplace report a whole bunch. Again, it's linked off to the right. We talked about the microinverter tax kind of slides, everything I've put into an ebook that is currently available on our website on the link on the right.
And then I also, because people often love microinverters and DC optimizers for their optimization, I couldn't help but add a optimization benefits calculator where you can see the benefits of the optimizers according to your own site's, electricity rates and how much reclaimed energy and other things like that you think you're going to get. We got another question. Are there any hardwire options instead of wireless for the monitoring on a module level? Good question. So at Tigo, we do wireless monitoring. And so that involves what's called a Tigo access point. One of those can handle up to 300 TS4s. So on a residential site, you probably only need, with those two orientations, you'd only need two of them wired with like an RS485 cable. Fairly straightforward. The advantage of wireless is we're getting that data at a super granular level, so you can see what's going on across a bunch of different parameters for each and every individual module. I forget what the number is, but we process an insane amount of data across all of our different sites. That being said, to be fully transparent, there are other companies that do PLC-based monitoring. So that's across the power line. It's just going to be typically less granular, less information that is accessible when you're doing it that way by the nature of the technology. So excellent question. Another one about battery usage recommendation in Florida. Whew. I'm not sure exactly what you mean by battery usage recommendation, but I did do a webinar with the man, the myth, legend, Greg Smith, who literally wrote the book on home backup and batteries. And in it, we talk about some specific tools that we've shared and created for how to appropriately size batteries for the amount of backup that you need. And that's specific to like power outages. Now, as far as utility rate plans, that's going to be a much more complicated exercise probably, that we'd recommend some design tools that should be able to go look at size of the solar installation, size of the battery installation, and what you can do. So it kind of depends on what you want, but if you're interested in just the pure battery side for backup, take a look, tigoenergy.com/webinars, and type in, battery in the search bar, and you'll see one that Greg and I did on that exact subject. Okay, we are about hitting our time. So we saw some awesome questions. We covered a lot of material today. Just want to make sure our emails are all available here. So if folks have follow-on questions or anything like that, don't hesitate to reach out to us. And again, this will be available on demand. So if you're like, this was so cool, my colleagues couldn't make it, send them the link and they'll be able to watch it from anywhere they want to watch it. So with that, I've been doing too much talking. Mike, Joel, anything you guys want to close out with?
No, this is great. Thank you so much for having me, John, Mike.
No, this has been awesome. I'd echo what John said, and even Joel too. The Energy Sage Marketplace report is a wealth of knowledge. Joel, you want to tip us off when maybe that second half one is going to be coming across the presses sometime soon? I hope, right?
Yeah, we're expecting it sometime soon. It's more of a matter of weeks. Okay. It's tough to say, hey, to make any promises, but we're compiling all the data. We're being very thoughtful about how it looks, what trends we can draw from it. So the goal is to have it closer to the end of this month. But again, we'll make sure everyone knows when it's been released. Yeah.
You're saying it might arrive before my refund coming there, maybe, if I fingers crossed about all that. I got my extension going. I got to get that one last fund in here on tax day. No, gentlemen, this has been a pleasure. This is awesome.
Yeah.
All right.
Thank you so much.
Thank you, guys. Appreciate everyone's time. We'll catch you next one. Bye.
Bye, everyone. Bye-bye.